Hi, welcome to today's episode for our show that we've been going on for a little bit for the Golden Path to Spring one. If you haven't been here before, welcome. We're doing basically two of these a week on Tuesdays and Thursdays up until we actually have Spring one, which will be connected with VMware Explorer. There'll be a little graphic at the end of this to tell you a little bit more about what's happening with that. So yeah, today we have Heidi Waterhouse, which is, yay, I did the correct direction, but my fingers disappear to this side of me, joining us. Can you tell us like a little bit about yourself?
Sure. So I am currently an independent consultant after 5 years working at a startup. And what I'm really interested in is how businesses deal with technological transformation. So, what is it that is actually driving the way you adopt tools and how you use them, and how you talk about the tools that you build to other people? So, sort of a DevRel for hire.
Awesome. Yeah, so the title of today's talk is Safe and Sensible Deployment and Launch with Reduced Risks. I should do this in advance, but I will paste the link to tell you a little bit more about what is happening with this in the chat. Right. So hopefully that link works. Yeah, so I guess you'll be telling us a little bit about like if if we don't have the ability to just go and be like, oh yeah, I'm just adding this new feature and putting this into the code base of how to go about dealing with all of that. And if anyone has any questions, please put them in the chat. I will be asking them at the very end. So don't worry, we're paying attention to you. So yeah, I will let you go and kick that off then.
All right. Thank you. Hi, I'm Heidi Waterhouse. I am here today to talk to you about safe and sensible, uh, which is an approach to thinking about how we manage risk. And as I was tuning up these slides for this presentation, I have to tell you that this is a great week to be talking about how to minimize your risks of unavoidable failures. So here we go. Why is there so much emphasis on speed in the CI/CD world? Doesn't anyone understand that it's important to be sure to release only the safest software? Move fast and break things is deeply unappealing in any kind of regulated industry or to anyone who does operations. It's not a great idea if, for instance, you're handling medical details or money. So, why am I standing in front of you telling you that you should go faster? Is this just like some kind of hotshot YOLO thing where I'm going to talk about speed being the way to everything? Am I spouting nonsense that doesn't make any sense for your environment? Maybe. But I think I have something valuable to offer you, a way to think about speed that doesn't make you less safe. This talk is not a book report on Accelerate, but it could be. Accelerate is a book about how deploying more frequently is often intrinsically safer and leads to happier teams. Dr. Forsgren did a ton of research in this book, and many of us have been reading the Dora reports for years that DevOps, now I'm going to forget it, what it is, the State of DevOps report. And it gives us a lot of very quantitative data on why it is that going faster can be a safer choice for our organization. So let's have some illustrations that may help you see why this works. Before we get into this, I just want you to ask yourself a question. How often do you deploy? And when I say deploy, we're going to get into this later. I don't mean release, that is, change something that your users can see. I mean, how often do you push things to production? Let's define our terms. What do we mean by fast? Fast is continually integrating and testing, and maybe deploying. It's not waiting for long release cycles or major revisions, at least internally. External releases and internal deployment don't need to be the same thing. There are good reasons why external changes are complicated. Every time we change something, users have to change their workflow, and it's hard. Safe, making sure that changes don't cause harm, and ideally that the change adds value. We worry about changes because we want to be sure that we are doing the right thing. If you make a small change, there's less chance of it going wrong enough to break something. This is the theory behind fixing typos. Unless you're using certain versions of Word, fixing a typo is not going to break the document. I like to think of it this way: it takes real effort to lose $1,000 at penny slots. You would have to keep betting and betting and betting. Odds are you'll need a break before you run out of pennies. It takes almost no effort to lose $1,000 if you're playing $100 blackjack because the bets are much bigger. What we want from our technology is the ability to make our bets smaller. You want the same thing for your deployment, to make it smaller, for your bets to be so tiny that losing some of them is small in the overall scope of what you're doing. If we can make our bets small enough, they're not so risky, and we can do them faster. Course correction. You want to just nudge the wheel a tiny bit. No sudden jerks, because that means an emergency can cause an emergency. I live in Minnesota, where I drive on ice, 6 months of the year. There's easily 2 feet of snow in my yard right now, and it was definitely freezing last night. So, what we learn about driving is that a sudden jerk breaks the contact of your wheels with the road, and it means that you're much more likely to skid. Even if you feel yourself losing control, you need to gradually respond and not panic. Being able to nudge your software gives you much more safety than needing to make 90-degree turns. My favorite story about this is the eBay colors. At some point, eBay decided that they didn't want to be the hideous yellow that they had been when they were born, and they wanted to move to something new and new century and maybe not bright yellow. And so they changed the website background to white, and they got immediate pushback. People who had been using eBay for years did not like this yellow or this white. It didn't feel like eBay to them. It was disconcerting. They were wondering if they were being scammed. It felt generic and not like their place anymore. So eBay apologized, backed up, put the yellow back, and then they thought about it a little bit. And then they set up an automation to gradually add white to the yellow, to decrease the intensity of the yellow day over day by just a little bit, so that it wasn't ever yellow to white, it was a gradual fade into white, and they got almost no comments about it because the people who cared about it were visiting the site often enough to get changes that didn't matter enough to rebel about. You need to be able to answer honest questions. A team at Microsoft once told me that software doesn't count as finished until it's in production, tested, and returning metrics, which I love. The idea that the state of finished is metrics and not just out is so important to our understanding of how it works. Nothing is safe if we don't know what it's doing. It's just not explaining that it's confused. Ask yourself a second question. Are deployment and release at the same thing in your organization? Is there any separation between I've pushed this thing to production and people see a business value change? Here's the spoiler answer. It's not. It's not the same. They need to not be the same. Deployment is the act of getting the code where it needs to go, and release is the act of providing business value to users. Once you start separating those in your head, you get so much more room for A/B testing and canaries and observability and all of the things that make modern development, CI/CD, work. Because release is something that product can make a choice about, not just the people who are doing the code. In order to do CI/CD, you really need to internalize that getting your code in production and letting users see it are distinctly different steps. Operational is not the same as perfect. Have you ever been delayed on a flight for something that seems completely trivial, like the latch bin is broken or there's a seatbelt that's not working? That's because planes are made of hundreds and hundreds of thousands of parts, and lots of them are critical for health and safety. There are some things that will obviously force an immediate grounding, but there are some things that exist in an error budget. And if too many things in the error budget go wrong, it indicates that the plane as a whole needs to be taken out of service and looked at carefully and tuned up. A lot of us have sort of innate error budgets in our life where you leave 10 minutes early for something, and that's usually enough time to absorb a little bit of chaos. And it's only when you spill coffee on yourself and you get in a fender bender that you don't have time to make it to your appointment. When we're thinking about what we want from our systems, we need to think about what operational is as a subset of perfect, as a percentage of perfect. What percentage of our system can be broken and people don't notice it? This is a thing that we also know about networks and network capacity. We've learned that computers and networks operate very poorly as we approach 100% capacity. That's because at 100% capacity, things break. It's much better to over provision the network and run at 80% so that if there's a sudden spike, we don't break, we keep running. When we think of that in software, we can think about designing our systems, our microservices, our known fragile parts to work effectively, even if they can never be perfect. Safety and psychology. It's always interesting when I talk about this because it feels so alien to how we think of code. But code is just a way of expressing ourselves to each other and to some rocks that we tricked into thinking. And if we don't feel safe in our changes and in what we're expressing, we don't make very good products. So let's look into that a little bit. You want to be trustworthy. You want people to know that if you've said an API endpoint exists, it exists. And if you said that you're going to pay them, you're going to pay them. It is essential for psychological safety that you communicate what is happening, not necessarily everything that's happening the moment it's happening, but that you trust people as partners. A system needs to be blameless. My therapist, my kids' counselors, and the character I have in a cartoon over my desk all say the same thing. Everyone is doing their best given their circumstances. People don't really maliciously fail. Or if they do, it's because of structural issues that they're reacting to. If they're doing things that seem harmful to us, it's because they're maximizing for something that we don't care about. What that means here is that we need to not to talk about people like they meant to screw up. They didn't. The system has brought them to a place that they cannot recover from. So when you're talking about what went wrong, remember it was never a person's fault. It's an accumulation of all the things. We need to make mistakes non-catastrophic. Mistakes are going to happen. We can work to minimize their frequency, but our systems are both complex and involve humans. So we can't get around the fact that mistakes will happen. So mistakes could be small, something that you could correct with a nudge or rollback or a flag flip, something that isn't about downtime measured in hours or costs measured in millions. It's a lot easier to do blameless when the whole incident report from recovery takes less time than the post event retro. My mistake was leaving my door open, evidently. Make your changes small and use steering techniques appropriate to your speed and vehicle. Curious. The best part of feeling safe is having room to be creative and curious. Why did it all happen that way? What about the system caused that? What could be different? What could we do differently in the future to respond to this? My wife used to do tech support at a university, and she had a great story about a monitor that gave one of her users all sorts of trouble, going out intermittently, but never making sense. She finally got the idea to walk around and look at what else was going on, and it turns out that the wall that the monitor was on backed up on a telescope or electron microscope. It makes sense in a university, but it is unlikely to happen to most of us. The problem was solved because she was curious and wanted to see the whole system of what was happening. This is what the observability people are talking about. We want the ability to ask questions that we didn't know we had before we needed to ask them. You can't predict it the way that you can predict needing to know something in a log. One of the ways we get to psychological safety is by giving ourselves guardrails. If we know there is something dangerous, we can work to add layers that prevent the bad thing from happening. Are you excited about the idea of Apple bringing back MagSafe connectors for laptops? Have you ever actually completely destroyed a computer by tripping on the cord? I bet you feel safer knowing that doesn't happen. This week, we're all talking about the FDIC, which is a kind of MagSafe connector for where we put our money. We have reduced the risk to some people to a tolerable degree with insurance. We do risk reduction in all sorts of places. We do vaccinations, we do anti-lock brakes, we do train gates. We are trying to prevent bad things from happening. That's one of the ways that we could be more safe. The other way is harm mitigation. Harm mitigation doesn't matter until something goes wrong. No matter how much we try to avoid risk, the truth is that bad things do happen. This is why we wear seatbelts and life vests and why we install smoke detectors and sprinkler systems and doors that swing outward. Ideally, we don't have fires in the first place, but if we do, we can design our buildings so that we don't die in them. We know that despite our best efforts, things will go wrong. And here are some of the examples of harm mitigation that we've added to our systems to make it a little less tragic. Seatbelts, building codes, RAID arrays. Feeling safe means that knowing we have a plan for foreseeable badness buffers us a little bit against that badness. This is what the chaos engineering people are talking about. When they say, make sure you know what happens when your system is stressed, this is what we want to know. So let's talk about the beautiful future. Where do we hope we are heading? In the beautiful future, a lot of our work has been taken by robots or automation. They're not smarter than we are, but they never actually accidentally add an extra space in Python. As we climb up layers of abstraction from machine language, we are getting closer to telling programs what to do instead of how to do it. After all, we can only tell computers how to be slightly dumber, if more patient, than we are. This is the airbag construction from the Pathfinder mission. It doesn't predict how the Pathfinder uh, will land. It just says it's going to bounce until it stops bouncing. And we don't know exactly how that's going to work out, but we know that all of the ways it bounces are going to be acceptable for landing. Bouncing is physics. And physics engines are now so trivial to write that we use them to distress adults with the game about the goat that licks things. We set some parameters and we let our computerized robot friends figure it out. Computers can teach themselves how to be smart and creative if we let them work things out in a structured way. The Go playing computer teaching itself novel moves is a great example. We didn't say, this is how to play Go, these are all the known human moves. We said, here are the rules of Go, knock yourself out. And it came up with things that we don't see in human Go players. It doesn't mean it's smarter than us, it just means it knows different things. And it's a lot more patient. Testing experience, but not intent. It's so easy for us to think of tests and test results as real, but they aren't. They are symptoms of the living and evolving organism that is software. We have so many layers of abstractions that we don't actually know what's going on, and we just sort of pretend that we do because we need cognitive handles to be able to grasp it. The sooner we change our thinking from this deterministic to this probabilistic way of thinking about software systems, the more we learn to ask the right questions. Doctors don't ask us how our thyroid is doing. They ask us about our skin and our hair, our heartbeat and our energy. Tests won't tell you that your thyroid is wonky. Instead, we test for the presence of your body trying to get your thyroid to work better. We test for thyroid stimulating hormones, which indicates that the thyroid is not working well. None of this is a direct test of the thyroid, but put together, we can have effective treatments. Think about your systems that way. Is it feeling well? Is it doing the things you expect? Is it doing some surprising things? It's worth asking. We also can't really tell what's going on inside our systems by direct observation because the important things that are happening happen in the spaces between the nodes that we can observe. Crucial events occur in the dark spaces between the stars where there is no light. We can infer problems because of symptoms like user experience, but we need a new way to watch for problems. And we need to understand what things are a symptom of a problem. Do all the things in production, maybe some staging, but you can't replicate the level of traffic and complexity and user weirdness other than in production. Not going to find all of the edge cases and problems in testing any reasonable amount of traffic. In a cloud native world, staging is a lie. We have enormous difficulty replicating the complexity, scale, interoperation, and generalized weirdness of production. For example, are you going to have additional licenses for all of your servers, your API endpoints? Are you going to authorize and pay for all of those? Have an experiment layer in production, an integration layer, and a stable layer. But it needs to all be the same system connected to all the same things. We are all testing in production if we think about it, because nobody has ever run software that didn't sometimes fail in production after passing other tests. We just need to admit to ourselves that sometimes that is testing data and we need to respond to it that way. So, what can we do about this state of constant breakage and unreliability? How can we make our teams feel like it's possible to try new things without taking risks? And how does going faster matter? Well, it depends a lot on how crucial your product is and how many people are using it. If you felt like I did this weekend when you're like, I don't even use that bank, but it turns out that's kind of crucial to the operation of the entire ecosystem that I work in, maybe the mitigations aren't enough. Maybe we need to talk about how depositor insurance works at amounts over, human range. Whatever your crucial thing is, you have to decide how essential it is. If Angry Birds goes down for an hour, I am merely vexed. I am not panicked. So, when you're deciding how much effort you put into mitigations, make sure it's proportionate to how essential what you're making is. Humans are really slow at reacting to emergencies. That's why we have circuit breakers. When something goes wrong, the system fails safe to a safer state rather than causing additional harm. We can also make sure that there isn't a cascade failure. Putting in stops to make sure that failure is contained to one area of the software or operation means that you can keep working at reduced capacity. Adding control points to your system allows you to react flexibly to problems by turning just parts of it on and off instead of having it all up or all down. Think about where you could add controls to bypass third-party integrations or known flaky servers. Think about how you could reduce panic and implement that. Disasters or catastrophes are almost never the result of a single failure. Instead, they are a collection of small failures that the systems of safety we have protect us from, most of the time. It doesn't matter that you put the lid on your travel mug wrong until you start to drop it and grab it by the lid. Remember this: failure is not the worst thing. Multiple failures are the worst thing, and every failure that you prevent keeps something from becoming a disaster. So, if this was too long and you read Twitter instead because it's right there on your computer or maybe your emails, if you want to release something often, make it safer and less scary to do so. And thank you very much for your time. This is Director Fury. I thought I had locked her up, but I had not. I am ready to take your questions now.
Director Fury is amazing.
She's very opinionated.
I could tell. That's the meowing, but just like watching her like go through the back was just, that was great because it's like, especially since she kind of blends in and then you see like a little bit of a tail just kind of chilling
Yes,
there.
I apologize for my work from home professionalism.
It's okay. Like I have this exact same thing if I have my bird around when I'm streaming. He is very, very vocal, and if he's out of his cage, he ends up like if my laptop is around, he finds it, and then I just can't do anything. So good job. Yeah, I
All right.
actually I really liked the analogy. I keep forgetting the difference between metaphor and analogy, but I think analogy in this sense that you made with like the thyroid and testing, like you can't, not specifically testing for that one thing. And I actually didn't know that. I mean, I haven't specifically thought of how do you test for like thyroid issues, and just like relating that to this is really cool. In terms of questions, it seems like you like answered the things as you were explaining them. But there is one that keeps coming up in general related to ChatGPT. So I feel like I'm just going to go and ask it.
Oh, yeah.
So they're wondering, what do you think about the future of platforms like ChatGPT and whether it can fully replace programmers just asking for curiosity?
So I think ChatGPT and affiliated, right, is super interesting because Cory Doctorow called it a stochastic parrot. And somebody else said it was like playing two truths and a lie. And both of these are correct. ChatGPT doesn't know anything. It is good at patterns, it's good at mimicking, but it doesn't understand what it's saying. And so I think that there's a lot of potential. Like, we're sort of using ChatGPT is an extension of predictive text in a lot of ways. And so when you start writing an email in Google and it says, "Do you want to continue this completely businessy sentence with the next businessy 5 words?" Yeah, I do, kind of. Thank you for not making me type those. When we're talking about using it for coding, it is entirely possible that the Cody next 5 words would be accurate. And there's nothing wrong with using it that way. Like, that's the whole Copilot idea. The problem that we have to consider is that we continue to sort of feed it recycled food. And the more code that we have written with it, the more it believes that's how code should go. And if there are any errors, or even like if it becomes old fashioned, it's going to be really hard to break it out of that path. So I don't think ChatGPT is going to replace coders any more than any technological advance has replaced labor. We just introduce more labor to make up for the fact that we've done a labor saving device. Like, we used to not have vacuum cleaners, and then we invented vacuum cleaners that everybody's like, "Yay, we don't have to like beat rugs on lines anymore. This is great." And then we introduced wall-to-wall carpeting, and now we have to vacuum for about as long as we beat rugs. So every time we try and save ourselves labor, we add a layer of complexity that becomes the new normal. It's like we have some kind of compulsion to stay in stasis, and not have a 10-hour work week.
Yeah, and there was a comment specifically about this saying, when ChatGPT can take requirements like this, I need you to write and deploy a migration for this old underdocumented ERP system in our unknown system to be able to send and receive invoices is when they'll be worried.
Yeah, I'm not worried. I'm sort of interested. I think that there are a lot of really interesting uses. I love the idea of using it for summaries. Notion keeps offering to summarize the things that I'm writing, and then it summarizes them, and I'm like, "You're wrong, but close." I think there's a lot of interesting uses for it. I just don't think that it's a very effective threat.
Yeah, I think if anything, there's a pretty long ways to go. I mean, it might be able to at some point be able to replace some of like some of the starting places for some people and some things of like just like some of the base stuff. But like I I feel like if even if it can just replace like some of the more intro stuff, they're still going to need people to start there, or you'll never have super advanced people if they never start in the beginning. So I just don't see it being able to completely like replace people. I mean, maybe if it does, I don't think I'll be alive. I mean, it's still pretty fast as to how this
Technology moves
technology
pretty
is
fast, but
advancing, but it
yeah.
is. But like, I just don't see in my lifetime that we won't need actual human programmers.
Yeah, and I think it's very interesting. I saw that there are more job ads for basically prompt writers, which is it's a different kind of creativity.
I mean, I guess worst case, it replaces all the existing software developers, and they just need them to work on these AI tools. So you still need
I
them.
I do hate calling them AI. Like, I think that
Yeah.
that's deceptive. Like, it's a large language model, or it's a predictive text, but it's definitely not AI.
Yeah. Yeah. I have one of my to dos that's because I'm bad has been a to do for a while is to like learn more about the whole like ML AI, like that whole space, because I just don't really know much of anything about it.
Yeah, and it's moving really fast, and there are not a lot of textbooks on it.
And if there are textbooks, they're probably not so valid pretty quickly afterward.
Exactly.
It's like, hey, ChatGPT, can you just like write this book about the current state and be correct so I don't have to like
That would be
keep changing
fascinating,
things?
like, very meta.
Tell me about yourself. Thanks. But yeah, thank you. Thank you so much for doing this. And also the little showcase with your cat. That was great too.
Yes. And, yeah, if y'all have any other questions, get them in real soon now. Otherwise, I'm gonna tell Tiffany about the book that I'm working on, so,
Oh, sweet. And
self-defense
also,
because I have
is this your Twitter handle?
Yes, that's my Twitter handle.
Yeah, so if you somehow don't get things in now, or if you're watching this later, because this you'll be able to see this on like YouTube and Twitch and all the various places, you can go and DM, or maybe not DM, message somehow in some way on Twitter to ask more things. But yeah, so book.
Right. So I'm working with a team to write a book on progressive delivery, which we think is the step beyond CI/CD, and it involves incorporating the feedback loop of not only how customers tell us they feel about it, but how they use it. So we need to understand all of these things about how we're building it so that we can continue to do these tiny iterations and get where we want to go, where the customers want us to go. And it involves having autonomy and alignment and automation and autonomy, alignment, automation. Oh, and abundance. Like you can't really do it if you don't have giant scale. But once you have giant scale and you know roughly what you want to do and you're all pointed the same direction, how do you know you're making the right thing? And so I've been deep in the thoughts of how this is going to work out, and I'm super interested to hear if anybody else has an idea on like the thing after CI/CD.
Oh man, I honestly haven't even just like specifically thought about the after. Like so much
Yeah.
of the thought is like, what is like, here's your, start writing your code, you have the code, and then here, okay, now deal with your like CI/CD, and then, oh hey, stuff is being pushed out, and you're like running it somewhere, and great, awesome. So yeah, that's
Yeah.
definitely an interesting place to be. Yeah, if anyone has any commentary, please put in whatever various chat system you're on. I guess, yeah, now that LinkedIn's connected, that also pulls in from here, since there were some issues before where the messages didn't go directly into StreamYard.
Ah.
But yeah, that writing a book, that's another thing that I have yet to do. I know quite a few people have done it, and it seems like a lot of time and effort.
It is. I like doing it with a team so that we distribute it, but um, my pandemic project was a co-written book on docs for developers. Like, so your manager is making you write documentation and you have no idea what that means. We wrote a little guidebook on help, how do I documentation?
That seems super useful. Is Where could people find that?
So it is from A Press, but it's just called um, Docs for Developers, and you can buy it on your local bookseller or from Amazon. And this month in Japanese. Um,
Oh dang!
here we're big in Japan. We're the number one selling software book in Japan this week. So
What?
I
Congratulations!
know.
That's awesome.
Congratulations to our translator who proactively reached out and said, "Hey, I think this book is useful. Could I translate it?"
Oh, that's awesome.
Yes. That seems
Yes,
great.
please do. I'm glad you find it useful. Yeah, no, that's really cool. Like, I feel like that's definitely a play, especially if you're starting like maybe a newer team or starting on a new project, of being like, hey, and you're not like, your job hasn't been, hey, write documentation. It can be like pretty overwhelming sometimes to be like, how do I even make this like good? And even if you have been doing it, like your team or whatever company has been doing it for a long time, I feel like there's always room for improvement on documentation.
Yeah. I mean, my first piece of advice is to hire a technical writer, but it's not advice everybody can take.
It's true. And random question, can you hear the wind that is trying to yank the door off next to me?
A little bit, or it could have been a large truck. Where are you?
I'm in San Francisco.
Oh, that is some weather you've been having.
Yep. I mean, I don't currently live here. I'm currently sitting in Josh Long's apartment. But yeah, anyway, I don't see any I don't see any messages further, so I think we will go ahead and wrap this up then. So thank
All
you
right.
again so
Thanks,
much for
folks, and
coming,
thanks,
and
Tiffany.
yeah, thanks everyone. All right, so if you are trying to learn more about Spring, or if you don't really know much about Spring at all, go to spring.academy. There are some courses that you can follow along and just basically learn more about Spring. Also, I kind of mentioned it earlier on. So there's Spring 1, which is this time it's co-located with VMware Explore. So that'll be happening for the one that it's co-located with. That's happening in Las Vegas on August 21st through 24th. So submit your CFPs because they are open now until I believe the 31st for both of them. Forgive me if I'm wrong, but go look at that and submit something ASAP. It'd be great to have you all there. And yeah, again, thanks so much, everyone.